In heavy-duty oil and gas processes, fluid streams transporting hydrocarbons, water, and chemical additives carry an ongoing suspension of solid contaminants, including silica sand, iron sulfides, rust, and pipeline scale. When these solids bypass upstream barriers, they act as a continuous, pressurized abrasive stream directed straight at a facility's most expensive machinery. For plant operators, mechanical reliability is a constant battle against internal wear. Upstream pumps, high-pressure valves, and downstream compressors are engineered to tight tolerances. Introducing hard particulates into these systems triggers rapid material degradation. Effective filtration is not merely about meeting a fluid purity specification, but is instead the primary defensive, keeping critical rotating and control assets online. To understand why filtration is critical to asset life, one must examine how suspended solids physically interact with metal surfaces. When hard particulates travel through high-velocity fluid streams, they cause two primary types of mechanical wear: erosive wear and three-body abrasive wear. Erosive wear occurs when suspended particulates strike metal surfaces at high speeds, acting like high-pressure liquid sandpaper that gradually washes away material. This damage is particularly aggressive in turbulent zones such as elbows, T's, and restrictor plates. Three-body abrasive wear occurs when a hard particulate becomes trapped between two moving metal surfaces in close contact, such as shaft and bearing. The trapped particulate acts like a miniature cutting tool, scoring surfaces and widening clearances. Common oil-filled contaminants like quartz, sand, and iron oxides are significantly harder than carbon steel, continuously scraping away proactive oxide layers and exposing raw metal to accelerated corrosion and fatigue. Pumps and control valves rely on high-pressure clearances to maintain pressure and control flow. In centrifugal and positive displacement pumps, clearances between wear rings, impellers, and casings are often kept under 1 millimeter. When abrasive particles enter these tight clearances, high-velocity solids strike impeller vanes and volute liners, causing severe localized erosion that distorts vane geometry and decreases discharge pressure and ruins hydraulic efficiency. Furthermore, particles penetrating mechanical seal faces score precision-lapped surfaces, leading to seal weeping and catastrophic bearing failure. Control valves, choke valves, and safety relief valves face seat erosion and spool stiction. Seat erosion occurs when abrasive particles cut across the valve seat and plug during throttling, causing internal leaks. Spool stiction happens when fine solids lodge into microclearances between the valve spool and body, causing sluggish response, sticking, or actuator jams. High-integrity upstream filtration prevents these solids from reaching critical components, ensuring consistent sealing performance and predictable flow control. Many facilities attempt to manage wear through a reactive cycle of replacing worn impellers, rebuilding leak valves, and swapping disposable filter cartridges. However, flexible filter materials like polymer fibers suffer from poor migration under dynamic pressure surges. As differential pressure increases, fibers shift apart, allowing a massive slug of abrasive particles to pass downstream. True maintenance stabilization requires stable particle retention, which is the ability of the filter media to maintain precise pore geometry under fluctuating flow rates and high differential pressures. Engineered metallic filter media, such as woven wire mesh, provide a rigid, non-deformable structure that offers direct financial benefits. Woven wire mesh eliminates bypass because pores cannot stretch or migrate, ensuring reliable particle capture. This dramatically reduces downtime by allowing downstream assets to run longer between scheduled overhauls. Additionally, it lowers consumable costs because robust metallic elements can be repeatedly backwashed and returned to service, slashing annual filtration budgets compared to disposable cartridge media. Thanks so much for watching. If you have any questions, click on our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things Hauver and Boker. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.